We're in Module 3 and we're going to do problem 9. Previously we had a look at some regression analysis through the use of trend lines. And now we're going to address regression directly through the use of the data analysis tool. In this particular problem we have data that shows us the sales of a particular product, or X, the dollar sales, and the corresponding sales and accessories and services that surround X. There are a lot of businesses that will sell you something inexpensively and then charge you for accessories and other services, for example, the telephone industry, that mean a great deal to their business success. So let's see how X and Y are related to one another. In other words, we'd like to take X and see if we can predict Y given what X is. And I've conveniently called it X here. This is the independent variable. Y is the dependent variable. So we're going to create a simple regression analysis with one variable. There could have been 2 or 3 variables, and I'll show you how to do that in a little while. So let's find the results of this, including the R squared, the coefficient of determination for this particular analysis, by first of all going to the data, and you can see the results out here. I'm going to go to the data ribbon. I'm going to go to data analysis. I'm going to select regression, and it's going to ask me some questions. The first thing that it's going to want to know is what is my Y input. So I grab my Y input. Let me just get rid of it and show you how I would do that. I'd grab my Y input, 78 data points. I won't grab the X because I've already done that. Okay, so the X input, well, let me do it for you. Let me grab this. A lot of stuff covering up stuff there. So got all the data now. I've got labels in the first, in the top of the column. I want confidence levels. I also want standardized residuals, and I want a residuals plot and a line plot. Okay, residuals and standardized residuals have a relationship. This is just standardized by the standard error of the distribution of points. So let's see what we get. I'm going to get it onto a new ply of worksheet. Here's the results. The results tell us that the regression is significant. Why? Because the significant F here is very, very small, smaller than 0.05. And so that means that the regression formula is a better predictor of Y. The relationship between Y and X is a better predictor of Y than if you just pick the average of all X's and say, well, this is what I think Y is going to be. So we have a significant regression. Also, the single variable that we have here is significant because its value is very, very small. This is like a p-value. This was a p-value in a sense. This is like a p-value here. It is a p-value, and it's very small, smaller than alpha. So the use of X is significant in the creation of this regression. Here is our plot. We can see the data is a pretty good fit. Here's our residuals, and one of the questions that I have in the problem asks about the strength of the residuals and how large they are. So first of all, we provide the data on the regression formula. The regression formula has a intercept, a constant of 39,911, and a beta coefficient in front of the X of 4.22. 4.22 times X, and here's our constant. This is our regression estimation. Okay. Then it asks also for the variability of the observed Y's from the predicted Y's. In other words, what it's looking for is the standard error of the regression. Misspelled. And that is given by the standard error. Here it is. It's often an important measure for how things are varying in the regression in terms of predicted versus actual values. And then it asks the questions, is this significant? It is not zero. In other words, given the test results provided, is the slope of the independent variable not zero? It is not zero. Why? Because we get a F significance that is smaller than the alpha. So the slope is important in this, of the independent variable is important in this model. Okay. And then finally, we're asked to look at observations that might be 2 standard deviations. The residuals are 2 standard deviations above the mean, and we can find those 58, 71, 72, and 73, those observations. If we look at the residuals here, the standardized residuals, we need to look at the standardized residuals, and here's our first one, observation 58. It is almost 3 standard deviations away from the mean. So this is a big miss in terms of prediction versus what actually happened in the model. And then there are 3 others that have residuals greater than 2. We're often concerned about these misses in terms of prediction versus actual value. If I had had more than one x variable here, I simply could have added that when I did my data analysis, when it looks for x variables, rather than grabbing just that one variable. I could have grabbed several along with the titles, maybe x sub 1, x sub 2, 3, 4, and it would do the analysis just like it did for this simple regression with multiple variables. All right, that's the end of our regression problem, and problem number 9 in Module 3.